Well, what we're going to do now is move into a roundtable discussion, but we have two other folks that are joining us that are here today, and I'm delighted that they're joining us, referring to Professors Mana Minkara and Sherry Shepard. And what I'd like to do is, let me start with Professor Minkara. Could you please, just introduce yourself and just tell us a little bit about your work? I really appreciate hearing that. Yeah.
Hello, everyone. I hope you can hear me well.
Yeah.
I am a professor of bioengineering at Northeastern University. I am at the beginning of my career. I started right before the pandemic. I basically computationally model pulmonary surfactants. That is, like, my degree is in chemistry, and I use a lot of modeling in my research, and I run a small lab right now. I currently am, I believe, one of the only blind people in my field. I don't know anybody else who is blind. And I really believe in engineering education being accessible to all. So, yeah.
Well, thank you very much. And again, I appreciate you being here, because part of, what we want to have here, of course, are these different perspectives. I mean, diversity is a word that carries many aspects to it, right? So thank you for sharing that. And we'll bring everybody in on this. And then Professor Sherry Shepard, delighted to see you again after many years again, like Alice, and just wonderful to have you here. Could you do the same? Could you just share with folks about your, please go ahead.
I'd love to. Yep. And I'm probably more at the end of the career than Mona, so it's great to have us kind of bookending stages of careers. I really appreciated how the speakers brought out some themes to me that were just very relevant to my pathway. About real world engineering is about partnerships, it's about relationships, it's generational, it's multidisciplinary, and it's interconnected. And I would say the NSF support that I've had over those years really helped foster that, not only in my work, but in the community at large. And I'll use as a little example. So when I finished my PhD, go blue, I took a job at Ford Research Labs and was working on developing an advanced finite element code to simulate crashes so that you could supplement physical testing of running a car into a barrier with computer simulations. And so very theoretical at that point. I just completed in the last week a project with Ford that's really looking at the innovation processes of their 10,000 product development engineers that are located around the globe, and how effective their processes are and what could be improved. And so my work really went from being focused on the technology to being focused on the people. And NSF enabled that. In one of the first grants with Alice, the Synthesis Coalition, we were deeply looking at, as she wonderfully summarized, educational processes that were more creative, which were more accessible, and really started to think about diversity. I then went on and had a grant from the Center for Advancement of Engineering Education with Cindy Atmans. So I was partnered with Cindy, where we were, increasingly bringing in social science and educational research methods to ask how well is it working, what we're trying to do with students. And then more recently, I was co-PI with Tom Byers on the Epicenter grant that was looking at this question of innovation being part of an engineer's education. So it's enabled me to transition from, making a better weld or better finite element code to really thinking about the key element in my mind in engineering is the person and who's doing the engineering and how they're working with various communities. So big fan of NSF. That's all.
That's great. Mona, let me switch back to you quickly. Regarding NSF, is there something you might share with us? Yes, go ahead.
Yeah, yes. So I am at the beginning of my career. I'm still applying for NSF grants, but I have been under the NSF wing. I mean, we can even start me talking about the impact NSF had on me from when I was a child, just being a PBS kid watching. I remember learning about, there was always brought to you by the National Science Foundation, the Magic School Bus and Bill Nye the Science Guy. That's the beginning seeds. But then when I was an undergrad, I had an NSF RU every summer. I was at Wellesley College as an undergrad. And that is where it all started. it really ignited my passion for research, like, really following the path of chemistry. And then when I was a graduate student, I got an NSF GRFP. So NSF has been part of my journey since the beginning. I'd have to say, and I'm very grateful for that.
Well, that's great to hear. I think, we all share that common bond, I think, because I was very privileged to have two different IPA tours at NSF. And I think one of the things that really struck me about that was, and Andre, you mentioned that also earlier, of course, the breadth that one acquires and seeing all these programs, but never having any question about, the value of what one is doing, right? Because the impact is, you don't even know where the impact is going to go. Harriet, you mentioned the goalie program, and there's a story I can share about how that was started, right? And so on. So it is a very special thing. But with that, there's a few questions here that I've been given to sort of put out in front of you and maybe sort of tweak a discussion here. And one of them, even though a lot of the work is coming together, of course, and we know that work is interdisciplinary, but there is a curiosity here about what, in your view, has been the most extraordinary engineering impact on society in your field of engineering, and thinking about the possibility that NSF might have helped catalyze something like that. And this is not pointed at anybody in particular, but I'll pick a frame on the screen if I have to, but if somebody would like to take the bait on that. Would anybody like to go ahead? Sherry?
Yeah. I would say, it's been incredible to watch NSF's maturing around what is diversity and what's important in changing who the faces are of engineering, and moving from its numbers only to really trying to understand what some of the structural components are that may make engineering not accessible, to also supporting work that, and Alice's work is a nice example of this, that really is community centered. And so I think there's been maturing of NSF's considering of the people and how important their support is for advancing who those people are.
Would anybody else like to share a thought?
I think one example I can think of would be, today, right now, we're speaking virtually. And in healthcare, telemedicine has definitely been booming through the pandemic. So one technology that makes this all possible would be voice over IP, or voice over internet protocol. I imagine perhaps the NSF may have played a role in funding the invention of that technology in some way at the beginning. So that's something I think that that's something worth noting.
No, I think you're absolutely right. Well, in some of the presentations yesterday and whatever, a lot of that development, has come through. You're absolutely right. So, Cindy, were you going to offer a thought there?
Yeah, yes. I was going to build on Sherry's comment and say also NSF pivoting to include, for a long time, NSF has been funding implementation of great programs in engineering education. And in the last several decades, NSF has enlarged that portfolio to really include research on engineering learning and engineering teaching. And that is doing a lot in helping us move the whole community to basing what we're teaching on evidence-based research on how engineers best learn. So NSF has been fundamental in broadening that funding profile.
Well, let me go along with that. Harriet, when you were sharing your thoughts with us, of course, a key part of it was the impact of even a small grant that brought you close to industry, right? That you saw that as something, I mean, that didn't happen overnight, but can you elaborate a bit more on that? Because I think that's also, go ahead, yeah.
Yeah, happy to. I also very much resonated with one of our colleagues who talked about, some difficulty getting traction with the first NSF grants, right? And so regardless of what mechanism And regardless of the amount, there is a level of capability and excellence that NSF insists on, but also helps to foster, right? So, you know, I'm sure my first application was was insufficient, you know, the first time that I tried. But I was encouraged to come and participate on a panel review for goalies. The program director, you know, specifically suggested some colleagues that I might talk to at other universities. My department at my first institution was pretty small. And, you know, each of those steps was important to that, you know, that success in landing that first grant. So of course, there's certainly a number of steps in between. Hearing industry speakers, getting out and, you know, taking additional deep dives with companies to understand their problems. And I've never participated in the I-Corps, but it sounds just wonderful in terms of, you know, formalizing the way that you can unpack and understand what's need to really align with industry. So all of that was certainly important early on.
Well, you really capture that with your hero, teacher, and mentor paradigm, right? Which I think we all really enjoyed. Andre, I'd like you to chime in on this one.
Sure. So, you know, I really, you know, kind of in the spirit of I-Corps have been careful not to talk too much about my technology. But you asked the question about technology and impact. And, you know, I spent 20 years in the fire protection engineering department at the University of Maryland. And, you know, I thought about, you know, the impact of a tech in that fire safety arena. And, you know, what came up for me was a smoke detector. And in that smoke detector, you know, there are sensors that are ion based, you know, so there are lasers potentially that can detect CO. You know, but what really makes smoke detectors effective is the policies around them. And so, you know, NSF, as we, and I still use we sometimes, so I'm still working on that, you know. So, you know,
you never really leave NSF, Andre. I've learned that you don't leave, you just get brought back, right?
So as they start really focusing on the translational space, with the TIP directorate, you know, bringing policies, you know, into that whole translation discussion, I think could be really impactful because there's the technologies, the use cases for those technologies, and then there's the adoption of those technologies. And when you talk about scaling, policy can be so impactful. And so I just wanted to include policy in our discussion of translation and impact, especially moving forward as NSF really tries, don't try, but really continues to innovate in the translational space.
Thank you. Alice, you're here with us, I'm assuming. Alice, are you with us, Alice? Hello, I don't know if
No, I'm here. Sorry.
Yeah, okay. Yeah, I didn't. Yeah, no, that's great. I just wanted to see if we could get your perspective on this too, right? You know, you've seen a lot happen in engineering across the years, right?
Well, a lot of people have already talked about things that I would have talked about. So what I think in my experience is that NSF has done and is look at big impact through partnerships and the coalitions and pulling together people from different universities, different types of universities, different types of institutions in industry together, whether it's in the entrepreneurship program or the engineering education program or the industry experience for research. I think that has had huge impact, and it's rare. You know, most funding agencies don't do that kind of thing at that level. So I think that has been quite impactful.
And Mona, yours is more recent, but is there a thought you could share?
So I think my thought is more about kind of the role, and like, just, I really like what Sherry said about the people-centric aspect. And I feel like even in my lifetime, and I'm still at the beginning, I could tell you the difference in even the change in the definition of diversity. Like, people were not necessarily, people with disabilities were not necessarily mentioned, but now there's programming. And now I think we're shifting towards even recognizing that people with disabilities could be doing science that's not even related to disabilities. And I personally feel like if there's an institution that would support the progress in which more blind individuals can enter STEM and contribute to STEM, it would be NSF supporting that. And I feel like that just does a lot. And that's kind of where I stand right now. Like, there's like two facets to my research. There's the research that I'm doing related to polymerase surfactant, which I love doing. But then there's the other side, which is making science accessible. How do I interface with it? We just created a technology where we use the concept of lithophanes through 3D printing. Like, all of that I feel like is stuff that NSF supports and would, progress. Anyway, yeah.
Well, I think, one of the things that all of you have brought out, or you've brought out one way or the other, is the things that NSF supports that probably nobody else does, right? Because, you saw some presentations yesterday, the progress of funding and whatever, but, many of the other agencies, and we get support in engineering from many of the other agencies, are very mission oriented, right? Whereas NSF, not necessarily being mission oriented, allows it that liberty. But what has certainly happened is this movement and transformation from NSF being at one time sort of siloed in its world of, say, basic to sort of the translational kind of work, right? And so I think that's really important. K through 12 at NSF. Arlene, I'm going to ask you to pick up on that, because you're already in that environment in a very special way, but your thoughts about more things that NSF could do in environments like that.
Thank you for asking that question. Within the K through 12 space, the NSF has done so much already. I remember in graduate school, there were lots of grant opportunities where we were able to do hands-on activities with high school students, doing really fun experiments with middle school students as well. The areas I think that probably the NSF could still lend an eye on, as I mentioned, I focus on invention education. While we focus a lot on STEM education, the type of curriculum that we offer there is usually where the teacher is guiding the discussion, where the teacher may say, okay, hey class, I want you to build the strongest bridge today. And, we're going to use toothpicks and marshmallows, and we're going to see whose bridge is the tallest. If we take more of an open-ended approach with invention education, you may say, okay, how can we go from point A to point B? And the students may build a bridge, they may build a car, they may build an airplane. And that way you're sort of encouraging kids to sort of think out of the box and be innovative or be creative. And invention education is it's very inclusive, so it brings in the arts, it brings in music. Cindy showed really something fun with the musical notes. So I think, the NSF being able to shine a light on invention education as well, maybe something that would be something that the NSF could focus on too.
Anybody else in the K through 12 environment, some thoughts that, many of you, Sherry, go ahead, Sherry.
Yeah, so I, for the last 10 years, had an RET grant, which is having high school teachers come and spend the summer at Stanford. And with those kind of grants, I think an interesting transition is in some ways similar to I-Corps and I-Corps-L, of how do you transition from NSF money to some other funding model. And so maybe there's an opportunity to help those PIs think about, in partnership with their university, of course, but more broadly of how do we get this funded in the long term? So because we can't be or shouldn't be dependent on NSF for a long time.
Anybody else would like to share a thought on that?
Well, that's a challenge. That really is a challenge. And so it probably isn't going to be commercially viable for financial sustainability either. There have to be partnerships with other institutions. We had a K through 12 component for our tensegrity robot, and We went to museums. We had a K through 12 kit, which we gave to some schools. But it was clear when we went through I-Corps that we're not going to survive as a company selling to K through 12 only. We had to do other things. And so I think what Sherry says, I absolutely agree with her, but I think we need to be creative about working with local and government agencies as well as state.
That's right. There's certainly room.
Go ahead. Yeah, Andre, please.
Yeah, there's certainly room, in the innovation ecosystem. And as you mentioned, Alice, local and state agencies to get involved, not only from perhaps supporting these types of educational initiatives for the good use of society and the local kind of public education system, but also there's a whole state innovation ecosystem that can step in as well. And so there could be some opportunities at that interface, where a local and state government gets involved from an economic development standpoint, as well as for a kind of public, local, and regional educational benefit perspective.
That's good.
One of the common themes, which is important, that's been coming out across this whole symposium, I'm not really saying it as well as I should, but the whole issue, of course, of diversity, equity, and inclusion. And Harriet, I know that you've written about your feelings that a real key part of this is this needs to be central rather than on the side. Is that on the periphery? Can you share with us your thoughts? I think we may be in agreement, but I just want to pick up on that with you. Yeah.
Yeah, absolutely. I mean, I think all of this in some sense perhaps touched on the idea or the ethos that inclusive excellence is not a compromise, but rather an approach, an ethos that's important in order to get excellence is inclusion, it is diversity. It is looking at ways to provide open opportunities for people to engage in that process. And, another point, I'll just underscore as I did from my talk that it seems to me, I don't know, I have not been involved, as close with a number of the other funding agencies, but it seems to me that NSF had this ethos, had this way of operating in terms of being inclusive and having program directors who are really invested in inclusive excellence before that was a term of art, a term of work that we're using now. It's been in the practice, it's been in the DNA of NSF as I have seen it. I think that it is so important to build on that. I think with that there is a lot more that we can do. I'll maybe go out a little bit on a limb here and say that maybe some thought processes of some folks in our community around broadening participation today, or are perhaps where some of the thoughts were of some in our community around engaging with industry partners 20 years ago. So it's very interesting to think about the opportunities to keep building on that and working on that and helping to elevate diversity, equity, inclusion through the work that NSF does.
Now that's an interesting analogy, because if you can indulge me for a couple of minutes, the first time I went to NSF that I was, Alice, you remember that's when we met. I'm going back into the 1989 time period, right? And I had been I was a young faculty member at the University of Florida with a colleague of mine. We started an industry university center, but it wasn't funded by NSF. It was a small Florida high-tech grant. And the main reason for that is my area is manufacturing systems, and our labs go out into the manufacturing facilities. And at that time, there was a lot of electronics manufacturing in the state of Florida, DOD and semiconductors or whatever. And I would get all this flack from colleague faculty members about, what are you doing, right? You should just stay here, stay in the office. What I couldn't understand is I had a neighbor who his expertise was snakes, and he was an academic, and he would spend 3 months in the Philippines every summer getting snakes, and nobody criticized him about going out into the field, right? And I'm thinking, what's wrong with this picture, right? What's wrong with the picture? I mean, like, somebody's not going to be, a faculty member at a medical school teaching appendectomies who's never taken out an appendix, right? So whatever. So long story short, the way to overcome that, the way we overcome it at that time is, and I think, Alice, you alluded to this and others, we wound up getting a lot of support and funding. And at some point, somebody had to acknowledge, right, Alice, that, well, this is creating energy, right? It's a good thing. So long story short, in 1989, the ERCs had started in 85, but at that time, the US was really under siege in terms of manufacturing. Semiconductor companies were going belly up in 6 months. It was a lot of the company. And NSF could not hide under the radar with that. NSF did not have a division of manufacturing. So this division of design and manufacturing was created. And somehow, because of this work that we were doing, and Alice, to your point, we also published in trade journals or whatever, somebody said, well, maybe Louis, a couple other people like Louis could help come in because they know how to talk to industry and academia and whatever. So I go to NSF, and I'll tell you the honest truth. First of all, at that moment in time, there were very few incentives for anybody in engineering to work with academia. In fact, there were disincentives. And at NSF, if a proposal came in with an industry letter of support, it was a kiss of death.
Oh, wow.
Why should NSF fund this? Industry should fund it.
Yeah, that's right.
Seriously, okay? I'm not kidding. And you're going to see where I go on this, Harriet, with that. So, I knew the impact it had because, again, the overlying word and a lot of what you've shared is a question of relevance, right? In other words, Arlene, whether it's these young people seeing what the impact of something is early on, or Cindy or Al, just having them see what they can do with the impact of this. So what we did in the division at that time was we said, okay, we're going to start a little program called an engineering faculty internship program, because we were getting proposals where people had the word manufacturing on it because they got the word that there was going to be funding in manufacturing. But I swear to you, you saw the word manufacturing in the first sentence, and then after that, nothing. So we said, no, these are internships for faculty to spend time in manufacturing environments. Oh, we've got faculty. And the way it went was, if you could get $1 from industry, we would match it with $1 up to X amount. So, Harry, the first grants, the max was 25, right, in terms of that. And it wasn't easy. And here's the thing about it. There was opposition within NSF. The division, the AD of engineering at that time, John White, we put it in front of him and he said, well, let me just check with some deans around the country about this. And basically the response was, well, if you guys do that, that concerns us, because then the faculty may leave, right? They're just going to go and leave academia. And so he said, Louis, you got to give me an answer to that. And I'll never forget, I went out that night, played a little tennis. I was younger, drank a little bit of sangria, came back the next day. And I said, John, the answer is, if we don't do it, we're definitely going to lose those faculty. If we don't create a pathway for engineering faculty who want to be engaged simultaneously in relevant environments, industry or whatever, we're just going to lose them. And to his credit and others, and it was a small program at the beginning, right? That's what eventually became Goalie. Okay. Harriet, you were going to say something?
Yeah, I just want to add to that, Louis. I mean, thank you for sharing that perspective and background. Of course, I know John White and can kind of picture how this, came about. But I think, the other thing that we need to do, and I know NSF and from other conversations, wants to be careful about, not treading across faculty governance or certainly university governance. I certainly understand that. At the same time, what I'm seeing, and it's only anecdotal, right, as we are recruiting faculty and striving to hire faculty in an environment that's very competitive with industry, is that we've got to also get beyond this mindset of faculty do X until tenure and then can start a company or do Y. I share with people all the time. I've got 3 daughters, all in college, and these young people are not waiting for us to get comfortable, right? So we really need to be thinking about all sorts of ways that we need to grow and innovate and update our models.
But let me just quickly finish and then I'll turn it back. So these programs started, okay? But it took a decade or more to start changing those paradigms, right? To the point, though, where a decade later, in many cases, if you did not have some level of industry support in your letters, you might have a hard time getting funded because then you couldn't show that it was relevant. All I'm really getting at, I think, Harriet, what you were saying, it took years to change something that seems so obvious to us now, right? And this is the evolution of, I think, what's happening with the issues related to diversity, something going from peripheral to becoming central. But I do think that the quest for that is really critical, because at least what I tell folks at our colleges, we will never be the college that we need to be unless we can accomplish that, because there's so much that would be left out. So, but in any case, so I've got one final question here. What advice would you give to students who are considering pursuing an engineering education? This is the advice for all these students that may be listening in or are going to see this program at some point. Wide open. Please, nobody. Yes, Alice, please.
Okay.
You're muted, Alice.
Create engineering on your own terms. There's a lot of flexibility in all engineering programs, and you can make it what you want it to be as a career.
Right. Thank you.
We are the people that define the field. We defined it intellectually, we defined it in industry, we define it in education, and we can make it in our own terms.
I would add to that.
Yeah, I was going to say, yeah.
Yeah, I would add to that, lean into ambiguity. Decades ago, when we talked about attributes that engineers need to learn, we would say that engineers need to tolerate ambiguity. And I don't know if you noticed in that list that I started my presentation with, the Harvey Mudd engineers, somebody said that engineers need to dance with ambiguity. And and I just love that. And we've moved from tolerating to dancing with. And I would encourage people to lean into the unknown and ask questions, because those are the frontiers that we need to be progressing into.
Yes, please, Mona, please go ahead.
I love that. First of all, this has been an amazing symposium, and I'm really glad to be here. I feel like I'm learning a lot myself. But one thing that I would tell students, like on top of everything that was just said, is even if you feel like it doesn't seem like it's possible to do, there are so many opportunities to still go for it, even if you don't know how you're going to do it yet. Like, just take it one step at a time. And there's so many opportunities to support you. Trying to articulate that very clearly. I can speak for myself as somebody who was told that like it wasn't possible to pursue the path that I wanted. And I had no idea how I was going to do it. But there's like so many opportunities in programming to apply for, to be able to pursue that ambiguous path. Yeah.
Oh, that's great. Sherry, go ahead, Sherry.
Yeah. I might suggest that they get out and talk to engineers. And sometimes we're hard to find. We're less than 1% of the adult population. And so that's why actually all of us have a role in being accessible or available. But really just seeing there are a lot of things you can do with engineering. There are a lot of paths. There are some bumps in the road. So really hearing those stories through learning to do information interviewing.
Arlene, do you have a thought you'd like to share?
I would say supplement your engineering classes with classes in the arts as well. Don't be afraid to take classes in the business school or public policy, music. You will be surprised at how you can marry those two interests, or in my case, literature. So yeah, don't be afraid to venture out of engineering and just try a class in a different discipline.
Let's see, Andre and Harriet.
So this may be advice for a little later stage, but get work experience, internships. So those could be even in high school, any opportunities that you have to connect with industry. And if you do start on your engineering path, getting those internships will really help inform the future direction that you may go in your career. Believe it or not, I still put my summer internships on my CV because they were so impactful in setting the trajectory for my career. So they're just fabulous experiences, and you can never start too early with that.
Any other thoughts? Let's see, Harriet, yes.
Yeah, I certainly will add that to really strive to connect to I will say, the moral authority of engineering. Humanity needs what we are doing, and expect that you can be very well trained as an ethical thinker, as a global citizen, and as somebody who is, it may sound a bit bold, but as somebody who can indeed change the world and make some tremendous impacts on some of the challenges that face us. And so just expect to do that. And ask a lot of questions, have people, draw people to your side, learn how the university works, learn about what your faculty are doing, and learn about what your colleagues are doing across the entire campus. I certainly agree with you, Arlene, that all of that is important and contributes to a rich experience to build yourself in a holistic way as an engineer.
Okay, well, thank you. I think with that, we probably have at least provided, the best feedback that I think we could provide to those that may be looking in.